Thank you for coming to our session on the Virtual Mystery Web Tool, online hybridized problem-based learning. The Virtual Mystery Web Tool is an online hybridized problem-based learning teaching tool that was created by students in computer science and anthropology at the University of Toronto, Mississauga, as a cost-effective way to engage students in large courses in collaborative small group problem solving. The web tool implements practical case scenarios in self-released, weekly open-ended clues and images to create a series of student projects. The flexible interface allows students to move back and forth between the clues, to engage with facilitators each week, and see other members' clues so that they can collaborate asynchronously within the web tool after they post their own research. Links to external resources and independent research requirements encourage creativity and independent thinking in the students. The virtual mystery web tool received overwhelmingly positive student evaluations over the last 2 years in an introductory course in biological anthropology and archaeology. And the user-friendly nature of the web tool has been attributed to student creators understanding the students' needs and capabilities and interests in an online environment. The web tool is being piloted in courses in the humanities, the social sciences, and the sciences at the University of Toronto, Mississauga, as well as the Department of Anthropology at the University of Guelph. So in the next 20 minutes, I'm going to give you a quick overview of problem-based learning principles, discuss the application of hybridized problem-based learning to large courses with limited resources, which is why we created the web tool, and to give you a quick demo on how the new custom web tool for the virtual mysteries works. So what is problem-based learning? Problem-based learning is a pretty well-established active learning method where small groups of students collaborate and work independently on a practical case scenario that has an open-ended solution. It's designed to encourage independent thinking and collaboration and self-directed learning in the students. So students take initiative by working in these small collaborative groups to learn about a subject based on what they've already learned or course material, but it's all applied within the context of a practical problem. And there's always a facilitator that is involved in the process of this collaboration as the small groups work through this collaborative research project. So in an undergraduate classes, it's known to encourage independent and critical thinking, as well as develop transferable skills where students use to apply theory and course material to these problems or practical situations. It differs from the traditional idea of passive learning, where students are given information from an instructor and from course materials, and then they regurgitate it or memorize it and reiterate it back in terms of assignments and tests. In problem-based learning, it's the reverse. So students are given a practical problem, and then they use previous knowledge to think about what information is missing from that problem and try to collaborate on different ways in which they could come up with solutions using their own research and their own process of critical thinking and problem solving. So all of the problems are practical case scenarios, and students are applying theoretical course material to these problems. So they're actually learning how to use theoretical knowledge to work within a particular field. In general, traditionally, there are 7 steps to problem-based learning. So students are given a problem or practical scenario or case study. They try to identify the key concepts and the missing information within those key concepts of the problem. And they brainstorm on this missing information to come up with or hypothesize probable solutions. Then they work independently on self-directed learning to, you know, uh, coalesce or gain these resources and investigate the problem to determine individual tasks and research. And then they come back together and assimilate their individual research to discuss how they're going to move forward in the problem solving. And they start to think about different methods that they're going to use. And then they write up results in this larger collaborative problem based learning report. So, what we wanted to do was we wanted to instill the principles of problem based learning, this small group, collaborative, active learning experience in a large course with limited costs and also restricted resources. So, we started with a course on the introduction to biological anthropology and archaeology, which had 800 students. It's a first year large introductory course, and we wanted to create an atmosphere of problem based learning by dividing the students into groups of 5 and giving them a small ongoing problem case scenario to work on. But we didn't have a lot of resources. So initially, we created these problems within the learning management engine, but it soon outgrew the capacity of the learning management engine, and we had to create a custom web tool. So, how the virtual mystery works is each week, each group of 5 students gets a unique case scenario. Each week, there is a new clue released towards that virtual mystery. So, they take basically a month to solve it. They think about the problem on their own. And once they put a comment into the virtual mystery web tool, then they get access to everybody else's comments within their group of 5 students. And then they can discuss back and forth asynchronously within the web tool what they thought about that clue. Facilitators go in each week and they can give feedback to each individual student or the group together as they move along before the next clue is released at the beginning of the second week. They go through this process again for the third week, and then on the fourth week, they coalesce all of their clues together along with any additional resources to put together a larger problem-based learning report. So what is the advantage of this web tool? Each student is given a link with their own password. Then they're given access to their group members and their individual virtual mystery. The clues and images that accompany each of the clues are auto-released each week. So students will put in their clue, they can go through the images, and there's also media links and resources with each clue. They put in their comments around it and their own investigations, and then they get access to their other group members in which they can go back and forth and discuss the research project together. So this is a good example of a initial clue or virtual mystery. A biological anthropologist at U of T is called into Canadian Customs for the contents of a suitcase that was found at the airport that contained probable remains of a primate. They have to determine whether or not this specimen falls under the illegal trade and export of primates. So for the first clue, for instance, they're going to probably try to determine if it's a primate or not using the course resources and other links that we've discussed in lecture and are supplied by the course. So I'll give you a quick demo. So students go in to their practical. We have 32 different practicals running, and we have 5 groups within each practical. They click on their group and then they choose their name after they've gone in using their student identification. They'll see a series of images in which they can go back and forth using the arrows, and they will see their first clue. So they'll see their clue prompts that gives them their practical scenario that they're going to work through as they switch back and forth through the images. Then when they're ready, they can add their own clue. Once they've added what they think their comments around the clue, Then it turns blue to demonstrate that it's been successfully submitted. And then they can see any other comments by other group members, which will appear in gray. And from there, they can go back and forth and reply to each other's comments as they work through the week. For the instructor view, the difference is they can see the images and the clue. They can also see the comments with the names of all the students and the dialogue of the discussion that they have with the web tool. But we also supply a answer key to the graders. So the facilitators can also see the direction in which all the students should be moving within the virtual mystery. And this is important because it's important to remember that each group of 5 students has their own unique virtual mystery. So it helps the facilitators keep all of the virtual mysteries straight. There are different ways in which the students and the facilitators can view the virtual mysteries within the web tool. So when if they want an overview, they click on overview and they can see where they are in the clues, how many group members have answered each clue. It will turn from pink. It will turn to pink from green once comments have been entered, and then they can see the dialogue and the student names as they move through the clues. Once they've moved ahead through the clues, they can go back and review previous clues through the overview. And this helps them to coalesce all of their clues after the 3 weeks to put together a collaborative problem-based learning report. This is an example of some of the problem-based learning reports. So in this virtual mystery, the group is assigned to the Toronto Zoo, where they're working as a primatologist. They have to address a lot of the concerns that are coming in for feedback from the tourists at the zoo, questions they have about certain pavilions and primates and different behaviors that they're observing. In the clues, they'll see images and links to certain primates engaging in particular behavior that the tourists are watching. And they have to create, this group created a pamphlet for the tourists at the Toronto Zoo to explain what they're watching within the pavilion at that zoo. This is another good example of a virtual mystery in which the group had to create a display at the Royal Ontario Museum that outlines some of the contenders for bipedalism in hominine fossils. They chose Sahil tugendensis as their example. They put together the display along with a report, a 6-page report, and they even included in that report gave a schematic of the way they wanted the display set up. And they also came with an interactive in which tourists or people that are going through the museum can interact with the display to ask specific questions about bipedalism. So what are the benefits of the virtual mystery project? It's cost effective, it's scalable to large courses. It gives a small group problem solving experience that's active learning and engaging to small groups of students in these large courses without added resources because one facilitator can facilitate and monitor several groups simultaneously. It's based on problem-based active learning principles, so students are learning independent, self-directed learning and problem solving, transferable skills, and critical thinking. And it's gotten a lot of very positive evaluations from students where they felt like they learned what an anthropologist does. They learned to think like a biological anthropologist to try to apply some of this course material to actual action. And again, it's multidisciplinary because we have problem virtual mysteries in primatology, psychology, forensic science now, and language studies. And it's the practical nature that seems to engage the students the most. So the take-home message is it's a problem-solving active learning experience online facilitated through this web tool. We've now increased the engagement in the web tool thanks to the students in computer science by creating a more user-friendly interface where students can go back and forth through the clues. They can access a number of different links and images through the web tool, and it's engaging students more through a guide now that we've created for the instructors with a template on how to create the virtual mysteries. We have a student guide that can be loaded up into the learning management engine, which explains the significance of problem-based learning and the virtual mystery exercise. So if you're interested to learn more about the virtual mystery web tool, please feel free to email me at s.fukuzawa@utoronto.ca. Thank you so much for coming to our session.